Okay, everybody. So we left off last day. Gentlemen, I want to start. Okay. We left off last day with example number 3 about this absolute value stuff, and I want to show you an example of how you might see absolute value in real life. By the way, how many of you know about things called day trading? Anyone know about that? You buy and sell stocks like during the day, and you make money that way. Anyways, don't try it. It's kind of like gambling, but let me just show you an example of what it's like. So here's an example. Okay. So, for example, on this certain day, the stock opens at a value of $20 per share. So that's the price of this stock. A stock is like something you buy that represents a part of the company. So it starts at $20. If you want to buy a part of this company, pay 20 bucks. But then throughout the day, it drops. So by 10 a.m., it dropped to $17. So the company wasn't worth as much. Okay. But then by 12 noon, it went back up to $19. It was worth more again. Okay. Then it fell to $18 at 1 p.m. and then suddenly it rises to $22 by 3 p.m. Okay. Then it says this stock finally falls to an unknown amount. Okay, so we don't know how it ended, but it was less than 22 at the close, meaning at the end of the day. Now here's the question. If the absolute value of the total change for this stock is $15, so if I were to look at all the different changes, regardless of if it was positive or negative, and I add them all up, it's 15. I want you to tell me the amount that the stock dropped in the afternoon before closing. Okay? So ultimately here's what you want to do. I want you to find me an equation that represents this, the total change. How do you find the change in something? It's always the new amount take away the old amount. Okay, so let's just write that down at least. Change is always equal to, let's say, the new value minus the old value. Okay? So there's a whole bunch of changes that happen on this day. The first change, I believe, occurs between the hours of the start till 10 a.m. What was the price of the start, or at the start? What was the price? $20. So that's my old value, right? What's the new value then at 10 a.m.? How much was the new value? 17. So I'm going to say new, which is 17, take away old. Now, because I said here the absolute value of the total change, meaning I don't really care if it went down or went up. I just want to see how much it changed. What should I put in front of this expression? How about the bars, the absolute value bars? Good. Okay. Let's continue on, by the way. The next change, what's the next new one? And what's the next old one? So now I'm going from 10 o'clock to 12 noon. What was the price at 12 noon? 19, right. So that's my new price. What's the old? 17. Good. Don't forget the bar. Okay. Let's keep doing this. The next change happens from, I guess, 1 p.m. to 12 noon. It went from 18 to, or from 19 to 18. So my new price is 18. My old price is 19. Do you see the pattern here? Okay. Let's keep going. You try to do this on your own. Okay. The next time, it suddenly rises to $22 by 3 p.m. So my new price is 22. My old price is 18. Okay. And then this is the tricky part. And then it says the stock finally falls to an unknown amount. I don't know what the unknown amount is, do I? So what should we do when we don't know something? X, okay. So here's your new, which is your final price. X minus, what was my old one then? What am I comparing this to? 22, okay. Now, what is this whole thing equal to? 15, bravo. This represents the total change. Change, 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 change. Add them all up is total change. Okay? All right, go ahead and calculate these things for me, please. Okay, can you simplify the first few expressions? Let's not worry about this yet, but at least do the first few in green. 17 take away 20 is how much? So that's -3, but the absolute value of -3, yes, is 3. Okay. 19 take away 17, I guess that's actually 2. The absolute value of 2 is just 2. Okay, so let's keep doing all these things. 18 minus 9, that's -1. 22 minus 4. Okay, now this one in blue, I'm just going to leave it as is for now. This is the scary part. Okay. But I hope we can simplify all these other parts here. Okay. Now, I hope you can simplify the absolute values like what I did. And then now my question to you is, what am I looking for? X. Just because it's X, I'm looking for X. Let's think about, what's X stand for again? X represents the final price, right? This unknown amount. So X, and I'll write this up here, X represents the final price of the stock at the end of the day. And once again, I'm going to ask you, is that what we're looking for? It's good if you can read, by the way. Read the question. Determine what? I didn't actually tell you determine the final price. I said determine the amount that the stock dropped in the afternoon. So that's another way of saying determine the change in the price. What here in this equation represents the change in the price? It's not 15. It's this whole thing. Yeah, I'm looking for this whole thing here. The absolute value of x minus 22, because this represents the amount that the stock dropped. Okay? Tricky. So let's figure this out. Okay? Let's not worry about what this actually is, but let's create that as my variable. What's 3 plus 2 plus 1 plus 4? 10. So I'm going to subtract 10 on both sides. So now I have here the absolute value of x minus 22 equals to 15 minus 10. What's 15 minus 10? 5. So what was the amount of the drop? 5. There you go. Okay? Now, before you turn the page, I want to make a quick comment here. If you see this last line that I have here, the absolute value of x minus 22 equals to 5, this is what I call an absolute value equation. Okay? For you who are thinking we're going to solve for x, that's meaning you want to solve or find out the missing variable x. Well, that's our next section, 7.3. Okay, so that's on Friday. Stay tuned if you want to figure out how to do that. Okay. All right. Let's turn the page. Okay. Let's turn the page. Oh, by the way, so Nathan, that question you asked me, you should be able to do now. Okay, because it looks like this one. All right. Yes, Sale. Yes, I'm sorry. Okay. On page 2 is where we start section 7.2. Okay. So 7.1, I kind of showed you what the absolute value is. You played around with it number-wise. Now I'm going to show you what the absolute value graph looks like, or the actual function. So to do that, I'm going to bring you back to good old days of grade 10 math. Do you remember graphing out lines?
Yes.
Yes? Let's graph out this line, y equals x. Okay? Let's do these values here. When x is negative 2, negative 1, 0, 1, and 2. What are my corresponding y values? This is not hard, by the way. The same thing, yes. Not trying to trick you yet. You know me. Okay? So I'm going to ask you to please go ahead and sketch these out, please. All right. And I know I didn't give you a nice grid, but if you can just quickly kind of draw in your dashes. Here's negative 2, 2. Here's negative 1, 1, 0, 1, 2. Okay. And if you were to connect all these together, what do you get? A line. Very good. So connect them together, please. Get a line. Let's see what you get. Okay. Wasn't math 10 so easy compared to math 11?
Actually, yeah, now I think about it.
You find the same? Okay. All right.
What do you learn reading?
Hey. Who's your math teacher?
You.
Must be the student fault. Okay, so ladies and gentlemen, can you, once you've done this line, see if you can now graph out the graph of y equals to the absolute value of x, okay? So what happens to these values when x equals to -2? Yes, the absolute value of x becomes positive 2. -1 becomes positive 1. 0 becomes, well, that's 0. 1 becomes, stays the same, right? 1 and 2. I'm going to ask you to plot these points now on the same grid. And let's see what happens. So -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. Graph it out. Yes, and then you know how I called the parabola the U-shaped graph? What do you think I'm going to call the absolute value graph? Yeah, the V-shaped graph. The L-shaped graph? Tilt your head some like other way. Okay. Okay. Now, once you've done all your graphs, I want you to think about this question. What differences do you see between y equals to x and y equals to the absolute value of x? What do we know about absolute values again? It turns everything that is negative into a positive. So you see how all these things down here are negative values of y? What did we actually do? We changed them. We took this point and we actually put it up here. We took this point, -1, and replaced it with -1, comma 1. So all the values which were below the x-axis now were put up to the top. Okay? So what I want you to understand is since the absolute value of x cannot be negative, right? Okay. The part of the graph of y equals x, okay, that's the red line here. The part of the graph of y equals x that was below the x-axis, okay, that's this part right here, below the x-axis. What did I do to it? Ah, I heard that lovely word. Reflected in the x-axis. Very good. Okay. Now, for this reflected part, so now I'm saying let's focus in on this part right here. What's the equation of that line, that part of the line that I highlighted in green? Oh, grade 10. Y equals to, yeah, y equals to what? Line x? Negative x, right. Do you remember this one? The slope, you see it's downward sloping. So for every 1 unit you go across, you're going 1 unit down. And then if you notice the y-intercept is 0. Remember all that stuff from grade 10? Y equals mx plus b?
We want to remember.
Remember, that's the equation of a line. B stands for the y-intercept. In this case, it's just 0. M stands for the slope, remember? Remember the slope song? Oh. Alright. Okay. Ladies and gentlemen, let's get back to me, please. Okay. Now, be careful. Watch this part. This is tricky, okay? Watch. Stay on. Johnson, please. Gabriella. Okay. Okay, Johnson, okay. So, can you see how the equation y equals negative x only works when x is less than or equal to 0? Okay? Rebecca. Okay? This is important. So this part of the graph, okay? This part of the graph to the left, notice that the equation is y equals to negative x because it's downward sloping like this, right? Okay, notice also why we put the negative there, and I don't know if you remember this from last day when we did that reflection stuff, the stuff you learned in grade 12, remember? Reflection in the x-axis means you put a negative sign in front of the value, so that's that there too, okay? Now notice what happens to the right. See that this part over here, which I will now highlight in blue? This part in blue, okay, no change, right? Compared to the line y equals x and the absolute value of x, it stayed the same. So I'm saying the part of the graph of y equals x that is on or above the x-axis, so once again, this is the part in blue, okay, is 0 or positive. So when I take the absolute value of a 0 or positive number, does anything change? Nothing changes. So therefore, that part of the line keeps the equation y equals x. Now, this is the big thing. Do you see how this is a V-shaped graph? Do you see how this is actually two different lines put together? Because there are two different parts, and I say here, because y equals to the absolute value of x can be written as two parts, this is something called a piecewise function. Those of you doing calculus next year, you'll see this a lot. Right, Rahul? Yeah. Okay. Now, what this means is that this function has two different parts, and it changes depending on where you are along your domain. So here's what I'm going to ask you to do. I'm going to show you how to write this as a piecewise function, okay? So the absolute value of x written as a piecewise function is written like this. It's the y equals to, and you put this big squirrely bracket so you can write down the two different parts. So there's going to be a part in green and the part in blue, okay? So let's do this together. What's the part in green represent? Well, that would be the part over here in green. So how do I describe this part of my absolute value graph? What's the equation again? Y equals to negative x. Good. And what's the domain? What are the values for x for this is true? Less than or equal to 0. Good. So let's write that down first, okay? I want you to write down y equals to negative x. And this is true if x is less than or equal to 0. Good. Okay. What's the other part of this piecewise function? That will be the blue part. So what's the equation of the line in the blue part? Y equals x. And what values of x is this true for? Everything bigger. Okay, bigger or equal to 0. Now, let me write this down, and then I want you to think about this. Okay. So once again, this is a piecewise function because this is made up of two parts. But there's one little thing about what you've written down here that I don't really like. Which one do you use when x equals to 0? The green one or the blue one? Both. Doesn't matter because they're the same. Okay. Correct. Both, or it doesn't matter, they're the same. They're both correct. But you know what my problem is here? If you write it down like this, I don't know which one you want me to use. I'm confused. I don't know. I'm not very smart. Okay, so let me just tell you this, all right? You have a choice when you do this in your homework. You can either put the equal sign on this one to the left, or you can put it on the one to the right. But don't do it to both, because you'll confuse people like me. So my advice to you, and this is what I prefer to do, is I always like to put the equal to the one to the right, because I like it because it's positive. And then this is just less than. Okay, but once again, if you want to be different, that's fine. You can write less than or equal to, and this is greater. Just don't put the equal sign on both. Okay? So go ahead and tidy up your notes for me, please, right now. I'm going to go less than, and I'm going to put the equal on the positive portion. Okay? All right. You want to be like me? Do like me. Now, there's one more thing I want to show you in terms of terminology. Okay? You know this 0? This value of 0? That's where the actual graph changes its direction. I call it the breakpoint. This is Mr. Lee's speak, okay? Mr. Lee speak. That's if you want to be like me. If you want to be like your textbook, there's a different name. Speak, speech. Okay, fine. Lingo. Tongue. Slang. Okay, slang's better. Yeah, slang. Mr. Lee slang. Okay. Now, if you don't want to use Mr. Lee slang and you want to use textbook slang, the textbook slang for this idea of breakpoint is this. It's called an invariant point. Invariant point meaning it's a point that doesn't change. I don't like it, but whatever. Invariant, 4 syllables. Break, 1 syllable. I like break. Okay? Once again, this is where the graph changes its direction. Okay? So, ladies and gentlemen, as a review, okay, just put down your pens right now. As a review, what I have done for you so far is I've showed you how to graph out y equals absolute value of x. It is, once again, a V-shaped graph that looks like this. Okay? It's made up of two parts, y equals to negative x, and also y equals to x. So therefore, we can write it as a piecewise function, x if x is bigger or equal to 0, negative x if x is less than 0. Okay? Are we okay with this concept right now? Good. Here's what I'd like you to do next. Can you, in example 4a, define the following absolute value function as a piecewise function? Meaning, can you write it like this with the two parts? Okay, first part, second part. And then I'm going to ask you also, can you sketch it out? Okay. Now let me try the first one with you together, and then I'll let you try B on your own. Okay. I'm actually going to do the sketch first. I want to show you the sketch part first. Okay? Now, ladies and gentlemen, just like how I sketched the earlier one, can you sketch out y equals to x minus 5 for me first? So just do a quick sketch. It doesn't have to be accurate, but just do a quick sketch of the line y equals to x minus 5. What do we know about the x-intercept for this graph, by the way? What's the x-intercept? Well, something's 0. Yeah, what do we make 0? X or y? To solve for the x-intercept. Y. Good. So if I ask you to find the x-intercept, you let y equal to 0. You get 0 equals x minus 5. X equals to 5. Bravo. So there's 5. And this slope is 1. So this is your line, by the way. Woo. There you go. Okay. That's y equals x minus 5. Grade 10 stuff, okay? Don't remember grade 10? Go back to your notes from last year. Okay. Now, I did not ask you to graph out y equals to x minus 5. I asked you for the absolute value of x minus 5. So what do I do to this line that's red? Reflect it, the whole line? So reflect it like this? Ah, yes, just the bottom part. Thank you, Hisham. So just the bottom part, reflect up top. And ladies and gentlemen, this is your absolute value graph I'm going to put in purple. Okay? Here's your graph. Now from this graph, I'm going to ask you to see if you can rewrite this out as a piecewise function. Okay? I'll give you a few seconds to try this on your own. Okay? And let's see if you can do it. Okay? Find the two pieces. Find the equation for those two pieces. Find the domain for those two pieces. Okay, let's take a look together. Okay? Shh, let's take a look together. Do you see that there are two parts, first of all? Okay, let's do the easy part first. The easy part is the one that did not get switched or get reflected. So that would be this part of the graph right about here. Okay? What's the equation of this part right here? Oh, I just drew in x minus 5. Good. So let's write it down first. X minus 5. No change, right, from the line. Same old. What's the domain, though? This is only true if x is greater or equal to, and this is that invariant point. You're correct. It's the x-intercept. It's 5. Good. Now, the other one, the side to the left over here, you're thinking, what's the equation of this line? Now, for those of you who want to go back to the good old days of Math 10, by the way, just watch right now. Don't write this down. Watch. This value over here on my original graph of y equals x minus 5, what's the y-intercept? What's this value here? Negative 5. So if I reflect it, what's this value up here going to be? Positive 5. This looks like it has a slope of 1. What's the slope of this part? 1. That's negative. So what's the equation of this line? Y equals to negative x plus 5. So if you wrote this down, you are correct. And this is less than 5. Okay? This and this look very similar, except for what? It's negative. So another way of writing this part Okay, I'll say or, you can write like this, negative bracket x minus 5. Okay? So do you see actually what you've done when you do the absolute value? You just take the regular equation of x minus 5. That's one part of your piecewise function. The other part is a reflection, right? And what did I show you about reflections last time? You put a negative in front of the whole thing. So you just take that regular thing and put a negative in front, and there you have it. This is the equation of that reflected part of the line. Okay? All right. You try part B right now on your own. Okay? You do it whichever way you want. Ultimately, I want you to find out the piecewise function and then a sketch of the graph, and then also do part C. Okay? Okay, let's do the piecewise function part first. Okay, it's always y with this squiggly bracket, and then what can you do? Well, there's always going to be a piece that's exactly the same as the stuff inside the actual absolute value, so just write that down. Now, the key part for this one is, what's the domain? X is what? Greater or equal to what number? Good. Where do you get negative 6 from? Just make the y 0, right. 1 half x equals negative 3. X equals to negative 6. Right. Remember, the invariant point or the break point always is when y equals 0. Good. So what's the other part of my graph going to look like, or the equation going to look like? Just put a negative in front. Yeah. Or I'll say negative 1 half x minus 3. What's the domain for this one? X must be smaller than. Right. Okay. Now, if I want you to now make a quick sketch, it's easy. Okay, remember, sketch doesn't have to be very accurate. Where's my invariant or breakpoint again? It's when x equals to what number? Negative 6. So 1, 2, 3, 4, 5, 6, negative 6, right there. And then what should I draw from here? V. Now, should the V look like this? Look like this? Or look like that? Which one do you think is best as my sketch? Fat one? Why? It's a half. Remember, the half means the slope is go 2 to the right, 1 up. So it's not as steep, so it's flatter. Exercise time again. Okay. No, we'll not do exercise. Okay. Yes, Rebecca. The bracket thing is a notation. Okay. So the weird thing about this is we don't close the bracket like that. We just open it. This half x here, distribute the negative. Half x plus 3. No, we don't need it anymore. What is it? Okay, shh, quiet please. Okay, to help Rebecca here, anybody else? This one in blue here, the half x plus 3, that's this part of the graph. Okay, that's the equation of the line for this part of the graph. The negative 1 half x minus 3 is the equation for this part in red. Okay? Remember, I'm trying to break it up. I'm trying to rewrite the absolute value as two separate pieces. That's what I'm doing. Okay? All right. Hey, how about part C? By the way, tricky. How many of you wrote this as your answer here? Y equals to 4 minus x. This is true when x is bigger than or equal to 4. And then negative 4 plus x if x is less than 4. That's clearly, it's too easy. What? Okay. Let's think about this, okay? Now, ladies and gentlemen, if you want to just watch, please watch. Okay, put your pencil down, just watch. I'm going to go back to our first principles. I'm going to actually sketch this out first. And when I sketch things out, I always like to sketch out the line y equals to 4 minus x first. So let's do that. What does this line look like? Grade 10 again. Describe it to me. What's the y-intercept here? Or what's the x-intercept? Tell me something. X-intercept's 4. Good. 1, 2, 3, 4. Does the line go this way or that way? Remember, this is minus x. The slope is the number in front of the x. It's a downward sloping line like, well, that's not a line. Like this. Okay? Interesting. Because now if I asked you to do the absolute value, what does the absolute value do to this line again? It takes whatever is below the x-axis and moves it up. So which part are you now reflecting? Is it the stuff to the left of the breakpoint or the stuff to the right of the breakpoint? Aha, you are right. Okay. So what does that mean then for our piecewise equation? Which part stayed the same? The left side. Okay, I will highlight this. It's the left side that stayed the same, y equals to 4 minus x. Where the right side got reflected, so what's the equation of the reflected part? Put a negative in front. Bravo. Negative 4 plus x. Now, this should make sense to you because this part is upward sloping. So if it's upward sloping, the x should be positive. This part here, it's downward sloping, so the x should be negative. So what's wrong with my piecewise function here? Now you can pick up your pencil and start writing this down. Yeah, let's erase this part. 4 minus x is the part now to the left. And the negative portion actually is the part to the right. So tricky. And the reason why this one's backwards is because you see inside the absolute value, it's 4 minus x, where all the other ones I gave you before, a and b, the x values, or the coefficient in front of the x was positive. Oh, my head hurts, you're saying, right? Okay. All right, ladies and gentlemen, let's move on to example number 5, okay? I'm going to give you a chance to try this on your own. Okay, I said graph out the following absolute value functions in number 5. And then afterwards, I want you to find the domain and range. And then I want you to rewrite them as piecewise functions. The same kind of stuff we did, except these functions are more nasty. So my advice to you in terms of graphing is to do the following, please. And I'm going to give you a chance to do this. Graph out always the line by itself without the absolute value. Then do the reflection stuff. Okay? Similarly, for the one in part B, I want you to first of all graph out the parabola, which I hope you remember. Angel, hold on. That's so random. Okay? Try, please, on your own. Shh, quiet, quiet, quiet. So this is how I would have done the first part, graphing out y equals 2x minus 6. There's my y-intercept of negative 6. The graph is a slope of 2, so 1 up, 2. Some of you might have actually found the actual x-intercept, which is 3, which is great. So your breakpoint here is 3. Good. Now the absolute value graph, of course, just takes everything that's negative and reflects. So let's do that. So if you think about this point negative 6, it becomes positive 6. So here is my absolute value graph right there. Okay? So ultimately, in the end, if you wanted to erase this line, that's fine, because this is your graph, okay? Just the V-shaped part. If you don't want to erase the line, at least maybe highlight this part so I know you understand this is your absolute value graph, okay? Ladies back there, please, okay? What's the domain of this graph? Domain, of course, talks about the possible x values of this absolute value graph. It seems like it goes forever and ever, both to the left and to the right, so we call this all real numbers. Sure. If you want to do it the proper way with all the fancy things, then it's squiggly bracket x with a bar. So this says x belongs to the set of, and you want all real numbers. Okay? How about the range? Yep. Hey, seriously, listen please, okay? If you got this done, that's great. Let's double check. The range here is y is greater or equal to 0. All absolute values, hear me out, are always going to be bigger or equal to 0 because an absolute value has no negatives. Okay, so there's your range. And then finally, the piecewise function. We have our two pieces. The piece that we don't change is the one to the right of the breakpoint, so that's greater or equal to 3. Sorry, this is 2x minus 6. And then the part that we do change, we put the negative in front. That would be the part to the left, so that should be x is less than 3. Once again, if you don't like to have the brackets, you can write this as negative 2x plus 6. That's okay as well. Okay? All right, let's do the more fun one. Part B. Okay? How do you graph out this? Okay, sure. Factor. Factor it for me then. What do you get when you factor it? Negative 2? Negative 2 plus 4? Like this? What do you mean, sure? Yes, negative 4 plus 2. Thank you. And if I asked you to do this and set this equal to 0, what's x equal to? Negative 2, 4. Can you see how all this stuff is coming back again now? All this stuff you learned earlier in the year? Ah. Now, you could make a quick sketch like this, but I want something better than a sketch.
Wait, whoa.
Yeah?
Whoa, why is it like this now?
Why is it a parabola now?
Yeah.
Hello? X squared.
Just, oh my.
Okay. Shh. Quiet, please. Okay. Shh. This is important. How can you do this for me, dear friends? Remember how I said I want to find that important point down here? What's that important point called down here? The vertex. How can you find the coordinates of the vertex?
It's too much for one thing.
Graphing calculator. True, but if you don't have a graphing calculator, what else do you do? Complete the square. That's one way, but that takes too long. What was an easier way? Okay, listen, please. Listen, this is important. You can complete the square if you wish. It'll take you forever. Instead, can you remember that when we look at a parabola, the parabola is what we call symmetric. It's symmetric about some line that goes in the middle. Remember that line? The axis of symmetry? Now, how do I find that line? Well, if this is symmetric, this is negative 2, this is 4. What's halfway between negative 2 and 4? Good. 1. So what you should know then is that your vertex has at least an x-coordinate that equals to 1, because it's halfway between. This is the easier way of finding the vertex, by the way, instead of completing the square. Now, what's the y-coordinate for this vertex at x equals to 1? How can I figure that out? Plug it in. Plug it into where? Right there. Let's plug it in. 1 squared is negative 2. 1 minus 2 is negative 1. Minus 8 is negative 9. Good. So let's graph this out nicely now. Okay. We have this point that's way down here at 1, negative 9. And this is what the parabola looks like. And that's just y equals to x squared minus 2x minus 8. Yeah, Rebecca. It'd be nice if you were actually paying attention. I know. So it'd be nice if you were paying attention. So you figure it out on your own, okay? So there's what you got. All right? Now I'm going to ask you to figure out where the absolute value is of this graph. And what do we do with absolute values? Stuff that is below gets what? Flip it. So instead of having this point at 1, negative 9, where is this new coordinate going to be? Positive 9. So here we go. This part gets reflected. And ladies and gentlemen, the one in blue is my final answer, which I will now put in purple. This is the absolute value graph here. W. Okay. W. What's the domain for this function, please?
X equals
Everything.
everything.
Good. All real numbers. Okay. Remember the parabola was everything, so the absolute value is also everything. But what about the range? The range for the parabola used to be y is greater than or equal to -9. What is it now? Right. Greater or equal to 0. Okay. Now the trickiest part about this one is to write the piecewise function. Okay. So really pay attention here. By the way, for those of you doing calculus next year, vitally important that you know how to do this. Okay. Tell me, how many pieces do you see?
3.
3 pieces. Good. I'm going to try to color code this. Watch. Blue piece. Green piece. And then we'll keep that as purple piece. Okay? Now, because there are 3 pieces, I guess I should make room for 3 different lines. Okay? 1, 2, 3. Now, before we find the equations, let's look at the domain of the different 3 pieces. Okay? The piece that is in blue, what are the values of x which represent this piece in blue? Less than 2, 2. Okay. So you can put an equal sign if you want. I won't. I'll say this one is if x is less than -2. Okay, that's the first piece. Sorry, I should color code this. That was not the green one. This is the blue one. If x is less than -2. Okay, now how about the green part? How do I describe the domain for the green part here? That's not how you describe it, Jan. The green part, -2 to 4, right. So the green part will be here. I'll say x is, the smallest is, oops. Oh, I wrote it wrong. Yes, I know, thank you. And I'm going to put the equal sign on this one. And then less than 4. And that last piece in purple, I guess that would be if x is greater than 4. Okay? 3 pieces. That's why I have 3 parts. Okay? Equal sign on the 4? Sure, thank you. Either or, doesn't matter. Okay? Roll back up? Sure. So once again, Betty, I have 3 pieces, right? This piece in blue, and the domain, the x values for that piece in blue is less than -2. Okay? The piece in green is between -2 and 4. And then the piece in purple, that's bigger than 4. Okay? Now, listen up. Which part got reflected? Blue, green, or purple? Green. So when something is reflected, what do I do to the equation? Negative. The other parts that weren't reflected, what do I do to the equation? Leave it. Excellent. Here we go. No change, so let's leave it. X squared minus 2x minus 8. The part in green, oh yeah, there's change. So what do we do? Put a negative in front of it. Negative x squared plus 2x plus 8. How about the part in purple? Same, no change. So I'll leave it like that. There you go, you're done. Okay. Now, can I ask you to try example 6 now really quickly? And then maybe I'll get you to try 7 at home, okay?
Oh, there's a challenge.
And a challenge one too. Okay.
Is this all our homework?
But number 6 is actually a graph now. Notice I didn't give you the equation. All I said to you is, here's a graph. Okay, here's f of x. How would you use this graph to sketch out the graph of the absolute value of f of x? What's different between the absolute value and the regular graph? What do we do with all this stuff that's down here? You move it up. Here we go. This part gets moved up. Yay! This part stays the same. The following part here gets flipped. Probably about to here, because this is -4, so that's +4. And then how about the part afterwards? Keep the same. That's it. You're done. The easiest question you'll get. Done. Will that be on the test? Perhaps. Anything I give you in my notes is fair game, right? Okay. Now, since we still have 2 or 3 minutes, let's just quickly look at example number 7. Number 7 is backwards, okay, where I have now flipped it around, made life miserable for you. Instead of you giving me the picture, I've given you the picture, and you find me the equation. Okay? Oh, interesting. So I got these from our graphing calculator. I just went to the graphing calculator. Let me just quickly tell you that this breakpoint here is the number 4. Okay? And I'm going to tell you this value here is 2. So I'm thinking from there you should be able to figure out the graph. So perhaps you want to rewrite this first of all as a piecewise function. And then once you got the piecewise function, you can convert this to an absolute value. Okay? So why don't you go ahead and see if you can try this. I'll give you, since there's 5 minutes, I'll give you 3 minutes to do it. And okay, let's do 2. Okay. Let's do 1. Anyways, just do it. And then if you finish this one, try part B as well. Okay? A lot of you are having difficulties even finding the equation or line. Please review the stuff from grade 10. Okay? This line, y equals mx plus b, is plus 2. You're right. And the slope here is negative 1/2. So the first part is negative 1/2 x plus 2. This is true when x is less than, I'll say less than 4. Okay? Now, what about the other portion, the one in green over here? Well, a lot of you are just saying, well, that's just the flip of it or the negative of it. Yeah, you can do that. So therefore, it's just positive. So positive 1/2 x. But don't write down plus 2. Because if I were to extend this line, where does it actually intersect? Minus 2. Right. Okay, and this is true if x is greater or equal to 4. Now, how do I rewrite this as an absolute value? Well, this is just the absolute value of 1/2 x minus 2. That's it. Okay? Done. Now, dear friends, to get you started on part B, I'm going to ask you to do this for homework here. This, of course, is a parabola. I hope you understand this is the coordinate 2, 0. This is the coordinate negative 1, 0. And I'm thinking, if you're curious about the vertex, I think it's halfway between. That would be negative. Oh, this is kind of not so fun. Negative 0.5, comma 2 point something. Oh, you don't need it. Why not? Oh, yeah! Dear friends, you actually don't need this, because didn't I tell you these part already? So you can find the equation by just doing this. X plus 1, x minus 2. Okay, ladies and gentlemen, I want you to try this one. See if you can come up with the piecewise function. Convert this. Also, yeah, of course you should expand it. Yeah, yeah. And then also try the challenge. I'll show you these two when you come back on Friday. Okay? Homework is all this stuff down here. Do as much as you can.